Okay, I've found something that I'm going to keep my eye on and keep in the back of my mind. This driver right here, I don't even know what it is. I'm just going through and analyzing with the small scope the signals on these drivers. And I've done this guy, I've done these two, they all look good. Then I'm moving on, and this one looked good. Then I get to this guy, and it has the middle signal there is the input signal, and then the driven output is on the bottom. And you can see this works right. The driver is working properly, but that input signal never goes low. It's always either floating or high. Now, every other signal on this driver, let's go to this guy. That's an input, and we'll go to its output right here and get a snap. You'll see this signal goes low and high, as does every other input on here, but that one just does not drive low, and I don't know if it's supposed to be like that. It's the oddball signal. So far this one had no floating out inputs like that. But this is the only one so far. I'm going to analyze this guy too. But so far this one's the only one that has a line like this, where it doesn't drive low, it floats. It goes high, but it does not drive low. And that is read on the scope as a high, which it should. That's floating. So it should, you know, high registers as a 1. Float registers as a 1. And depends on where the threshold is. It could be a 0 too. But it's definitely not driving low. So I'm going to remember this. I'm going to think about this and continue, because it may just be a floating signal that goes high. I don't know. But I'd like to know what's creating that signal, where it's coming from. And I will find that out. But as for right now, I'm going to move on. This driver's working as it should. So that's not an issue. Even though that's a funky looking signal, I know that's not a problem with this driver. So I'm going to move on. Okay, I printed off this part of the AVG board. It's all the RAM and the vector ROM, the address buffering, the data interface right here, buffer. What I'm looking at is that one N, remember? That was this guy I said had a floating input. Well, I probed around and it's on pin 13, which is address bit 2. Address bit 2 into that thing, which is pin 13, 11, 12, 13. And absolutely that address bit is floating. It's half floating. It will not drive low. That's address bit 2. So that is definitely, that's a problem right there. It's address bit 10. Address bit 10. So what I need to do is find address bit 10 over here. So let's do that. I'm going to look at the addressing, because that's direct AB. That's AB10. That's straight from, it's straight driven from this board through the connection over to here. I mean, it could be bad connection, could be, I don't think so, but we'll find out. I'm going to find address bit 10 over here, driven off of the buffer, and we'll see what's up. All right, this. See it? That's address bit 10. The trace coming off of this pin is address bit 10. It's broke right there. and that comes down and goes straight to right here, and then over to the other board. So it was one broken trace that I missed. So I'm going to fix that, and then I'm going to do another double take, another double check. So let's do that. Okay, and I just kind of cleared the trace and jumped the solder over to the trace, soldered it to the trace. Made the connection, so let's go ahead and hook everything back up. And I double checked everything. I don't see anything else. So we'll see. Let's just hook this thing back up and see what we get. Alright, well, after repairing that trace, I've got it hooked back up, and it's looking like it's working. So I guess we can go ahead and hook the soundboard up and put it over on the vector monitor. Let's go ahead and do that. Sound does not work. And we have to adjust this thing. Down with you. I sprayed all the pots with deoxit, and I moved all of them. I worked them all, so it's way out of adjustment. So let's put it into test, and let's reset. And I want to adjust. So let me set the camera up, and we'll do some adjusting. No errors. That's good. Okie dokie. Well, let's start with I don't know exactly. I want to start with the BIP, the bipolar pots. And there's a screen that you can get to where it says line up the boxes. Right here. Let's line up the boxes. That's pretty good. Linearity looks good. That looks good. Switch test. Oops. I don't even know what I did. Let's restart. Okay. Okay, I think we have matrix errors. No divider errors, but we have matrix errors. Okay, interesting. Right thumb, left fire. right fire. And let me hook up the pots. Make sure the analog is working for the yoke, the flight yoke. Okay. Here we go. And it's working. So that is good. I'm going to take it out of test. Yeah, see the star field, the stars and whatnot. It's not working. Yeah, matrix errors. That is a mainboard problem. Soundboard issue. But we're pretty close to having it working. Yep, we're not doing that. Okay, so we got issues. We have soundboard issues and we have matrix errors, which that should be in the manual. I'll look in the manual about matrix errors and, you know, see what that might mean. Yeah, this thing's got a problem, big time. That's okay. There ain't much to this. There ain't much to that at all. I'll have to just probe around, make sure all my signals are getting over here. That's number one. I think the data is latched through this guy. So I'll just make sure that the data is all at the inputs of this thing. It really shouldn't be much to fix that. I've already verified the pokies are all good on another board. So. And I don't know about this interface adapter. I don't know. I don't know about the RAM. The speech chip is probably okay. You never know, though. But I do need to test this stuff. And the ROMs, I have no idea if the ROMs are any good. I got some testing to do. I really should. You know what? Let's just get this thing out of here. Let's focus on the matrix errors. Let's get this thing fixed 100%. And then we can move on to sound. Sounds like a good plan of attack. Alright, I promised that I'd come back if I found something interesting. So what I was doing was I was probing around on this, and I was looking at these counters. They are block index counters. And they provide these address, basically these BIC, block index counter bits, 8-bit, 9 bits. Okay, a 9-bit address, basically those BIC files, and they are up matrix processor address selector, and it's basically muxes that multiplex those BIC bits with the CPU's address bus. Basically, is how that works. Okay, so the CPU looks like it has access to it, as well as the matrix processor hardware. What I was finding when I was looking at these guys is this one was never being activated, ever. This ripple would never go low, meaning this was not terminating. This, and I looked at, I put the analyzer on all of these 191s, and over here there's a couple more, and I didn't see anything to where they didn't work. They were doing what they were supposed to do. Yet, this thing never, this ripple count would never go low. This would never be activated, and this, you know, this just wouldn't do anything. But I didn't see anything wrong, so I was like, well, okay, maybe this thing isn't being allowed to terminate. Right? That's the only way this is going to send this ripple, to activate this. And this is the whole addressing to the matrix processor. So I was like, okay, well, let's look at what's controlling this. We got a load signal, and that's MW2. So I found MW2. It is, and then I was like, okay, I need to start at the beginning of this math stuff. And the beginning is the addressing, the address decoder. That's the beginning. This starts with the signals that start everything, right? So I'm on this guy right now, analyzing it. And if you see here, up here, you know, it's enabled on 1. So I'm triggering on 1. And right there is 1, and it's enabled. And we've got 6 on here. So we should have the 6th bit going low. And we have the 012 bit. Instead of the 6-bit, it's sending the 2-bit low, which the 2-bit is MW2. If we come to look at MW2 in here, MW2 is right here, which is loading this guy. It's reloading it and not letting it terminate. So this thing is being stopped from counting too soon. So it's not, it's just, that's what's going on. It's terminating that count before it should. This guy right here. This 138 is not good. Let's see. Okay. See here, 1, the 1 bit is low. The 6 bit is low, and right here, you can see right there, it set that bit low again. And it's trying to do this 6. This guy right here, 6, is this signal. It's a video. It's a you know, it's a digital vector signal. That's not, you know, whatever DVD DH stands for. That's not getting enabled. Instead, it's enabling that signal too much, and it's resetting. It's not letting that's not being allowed to terminate. So it's messing the whole address up to the matrix processor. So I'm going to stop, and I'm going to replace this 138 and see what we get. Hey guys, I'm just going over this video that I made a little bit before I put it together and post it and all that good stuff. Excuse me. The 138 that I replaced, I touch on it at the end of the video, but I wanted to jump in here. That didn't solve this issue. but I think that might have had a hidden problem that I hadn't gotten to yet. I really don't know, but that wasn't the major issue. So I just wanted to jump in and tell you that. But it definitely did look wrong. But it's hard to say because that didn't fix the problem. But I don't know if that was masking another problem. I really don't know. But anyway, back to it. Okay. I have gone through this board and green dotted and tested everything in this math, the accumulator, the registers, the multipliers, all of the control that's involved with all of that. I have gone through and green dotted so much stuff on this board. Doing the easier stuff. And I found no problems. So I went to the more, I guess, complex type chips, if you will, you know. And these are registers. These are 165s, which a 165 is just a shift chip. So I started looking at these and I was like, you know what I'm going to do? I'm just going to jump these and see what happens instead of analyzing them. I'm going to see if I can get lucky. So I have one at a time jumped that one, and that one until all of the errors cleared up. No matrix errors. 3 of these chips are bad. 3 of the 165s. So I got lucky by jumping these and it cleared them right up. See, I'll remove this one. Let's remove this guy. 2 of my errors, or 1 of the errors shows up. And if I remove the others, let's remove this guy and this guy. All of my errors are back. So I did get lucky by just being able to jump those, and it cleared them right up. So it was this one, and this one. So I'm going to go ahead, stop, tear this apart, replace those 3 chips, and then come back. I believe we have soundboard problem yet. Alright, we replaced the 3 chips, 3 165 shifting chips, and we now have a perfect picture. I do have it shrunk down a little bit. I don't need to drive this monitor all the way out to the corner, so I always bring the screen in some, and you know, customer can adjust it the way they want it. Yeah. We'll enter gameplay mode, and we should see we should see everything looking right. I don't even have the soundboard hooked up. So we'll go ahead and coin up and start. Let it count down, and we should see everything looking right. And we get down into that trench for the trench run. Yeah, see, everything's looking great. Just like it should. Vector graphics are so cool. There we are, in the trench. Okay, so now we will just hook up the soundboard and see what we got going on there. I know that the interface is good from this board to the soundboard, because I tried another soundboard on this and it worked. So I cheated. But hey, if you've got a good soundboard laying around, it helps to do that. So let's hook the one that came with this set up and see what it does. I think it's bad, but we'll find out. That's... uh-oh. We may have bad sockets. There's no voice, that's for sure. These pokies are all tested good. Yeah. Yeah, that's more than sockets, I believe. We got issues on this thing. So... Alright. Alright, we'll take a look at it. It shouldn't be that difficult to figure this thing out. Alright, well, I had the scope out and I was probing around, and the signals from the CPU board come in on this guy, and then they're latched and sent over this, and and then it went back over to here into the CPU board, I believe. So it's kind of a latch loop, and you can see that right here actually. This is where 5J? Yeah, 5J. This is where PD 0 through 7 come from the edge onto the soundboard, and then it goes right to here to 5J, and it's latched and becomes sound data, which that sound data goes to the board, goes over to here, the CPU, and goes to the RAM, and every sound data everywhere on the board. And it also is latched back to the CPU through this guy. Well, I was looking at the signals coming into here and out of this, and one of them was floating. It was floating, and then it would go high, but it wouldn't drive low on this guy. So I just replaced this, and I believe that we have fixed our problem.
Good 5 standing by.
Yeah. So just that chip right there. Excellent. So as always, we will go ahead and as always, I will go ahead and set up the camera in front of the monitor, and we'll do a little play testing, make sure everything's working as it should, and put a bow on this one. Okay, we're ready to give it a shot. Let's go ahead and coin this baby up.
The force will be with you.
Yes, it will. Yes, it will.
Red 5 standing by.
Oh, let's go over to easy.
Come on.
All right. Excellente. So, this board set, what did we do? Up here I did everything I always do. Replaced the regulators and the op amps and socketed them. I had to replace this ROM with a ROM I had kicking around. So from a spare board, so I don't know where that ROM came from, but I had this actual ROM. So I just swapped it, popped it in there. AVG chip was bad, so I got a new AVG chip. Over here, let's do this. I got my test stuff hanging around. Let's move everything out of the way here. You know, let's toss these in there and move this stuff out of the way. Put this up. Thank you very much. Okay. Let's move all this junk and let's set this over here. And let's move the book. My big TTL book. Alright. Oh, almost dropped my camera. I had to reprogram Star Wars ROMs, because remember, this thing had been converted years ago, back in the 80s, to Empire Strikes Back, and that kit from Atari came with a little board that plugged in, I believe, right here, and it had a couple ROMs on it and a couple ICs, and it also came with new bipolar ROMs up here for Empire Strikes Back, so I had to burn new bipolars for Star Wars. new Star Wars ROMs, and I replaced these sockets. I replaced all of these sockets. I replaced this 138. If you remember, that thing was acting funny. I replaced it and it made no difference. Yet it was clearly looking like it wasn't working right. I don't know. Looking back, I don't know if I was hooked up on it wrong. I really don't know. I did re-examine that off camera. I re-hooked up to that and it worked perfectly after I changed it. But if you remember, it did not look right. But anyway, I replaced it. Now it was working perfect as it should after I replaced it. So that may have been a problem that we fixed that we didn't see because of these. I don't know. Anyway, I replaced these 3 chips. I had lifted these 384 multipliers out because I didn't want to test them. I just wanted to replace them and see if that was my problem, and it turned out it wasn't my problem. So I put the originals back in the board and the subtractor. Instead of analyzing those, I just lifted them up and socketed them and put new ones in just to see if that was my problem, and it wasn't. I did that early on, but that wasn't my problem, so I put the original chips back in the board. And these sockets were replaced. This socket, I replaced the header because it was really bad. Look at all this analyzing I did do. I analyzed that. 1, 2, 3, 4. 1, 2, 3, 4. And I know I analyzed these. I just didn't mark them. So 5, 6, 7, 8, 9. I know I did that. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, or over 30 chips I actually analyzed doing this job. I got to everything except for where the problem was. But hey, all of the signals that I looked at, the integrity was really good. There was no flakiness on any of those signals. Everything looked great on this board, so that's good. That's it for this board, I believe. And I washed everything too. This board, everything was tested, of course. This chip was bad. I cleaned this board up. I cleaned that up. I cleaned the tarnish off of the legs of that guy. Yeah, just had the one bad chip right here. And that is it. But as always, thanks for watching, everyone. Subscribe, like, leave me a comment. What'd you think of this one? This was a pretty involved repair. You know, it's kind of a challenge, but it was fun. All right. We'll see you on the next Classic Arcade Repairs. Thanks, guys. Peace out, and see you next time.